class, another technique and tool that we're going to have in our toolbox that will help us determine the structure of molecules is this right here, the index of hydrogen deficiency, which we often abbreviate like this. Now, when I took organic chemistry, I used that phrase, degree of unsaturation. I use them interchangeably. Right? So if I say degree of unsaturation or index of hydrogen deficiency, I use it. It means all the same thing to me. And it should mean the same thing to you. Now, spoiler alert, who cares? Why is this so important in helping us determine the structure? Well, what this does for us, okay, is if I have a molecular formula like this, if I can figure out the degrees of unsaturation, that degree of unsaturation can help me determine the structure. So it could mean, hey, if I have a certain amount of degrees of unsaturation, that could tell me, hey, maybe the molecule is a cyclo. It's a ring. Or the degrees of unsaturation can say, hey, that structure could also be an alkene. So the goal and the reason why we use degrees of unsaturation is because it can take a molecular formula and then give us an idea of what it potentially looks like. Now, degree of unsaturation by itself can't tell us the structure of a molecule. But with mass spec, degrees of unsaturation, an IR spectrum, and an NMR spectrum, all of these techniques combined will help us figure out the structure of a molecule. But degrees of unsaturation gets us started. Because, or does the molecule look like this? Just a simple alkane. That's why we are going to look at degrees of unsaturation, because it's going to help us figure that out. But before we delve into that, we need to understand some guiding principles to that. So I'm pretty sure all of us have heard the term saturated fats versus unsaturated fats, right? What does that mean? Well, it has to do with something like this. It's a concept that for every carbon atom in a molecule, it has the maximum amount of hydrogens possible. That's what saturated means, or that's what saturated fats are. Saturated fats, all the carbons have the maximum amount of hydrogens possible. So for another example, if you look at ethane right here, do you see how every single carbon here has the maximum hydrogens possible? This hydrogen, or carbon 1, the maximum amount of hydrogens it can have is 3, and it has 3. Carbon 2, maximum of hydrogens it can have is 3, and it has 3. So that ethane molecule is saturated. But if you compare ethene, drawn here, do you see how we still have 1, 2 carbons, just like in ethane, 1, 2 carbons? But look at carbon 1. It now only has 2 hydrogens when it could have had 3. And same with carbon 2. It has 2 hydrogens when it could have had 3. So this molecule right here is going to be termed unsaturated. So this one is saturated right there, and this one is unsaturated. And that does not. Now, when you come back to fatty acids or saturated fats and unsaturated fats, the molecules look a little bit different. they're just really, really big. So if you take a molecule, it's just really, 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 really long. Okay, lots of carbons. So that would be a saturated fatty acid because all these carbons right here have the maximum amount of hydrogens. But if you look at another fatty acid, and we put some double bonds in there, that would be a unsaturated because these carbons right here don't have the maximum amount of hydrogens. Okay? So saturated, unsaturated. That's the definition. Now what's interesting here is I'm going to have our reference compound right here. Okay. So I'm going to have our ethane right here so we can refer to it. Now the index of hydrogen deficiency or degrees of unsaturation, okay, here's the trick. For every additional double bond, that is 1 degree of unsaturation. So here we have ethane in red here. And when we add a double bond between those two carbons there, what happens? We have a degree of unsaturation or an index of hydrogen deficiency of 1. And for every 1 degree of unsaturation, how many hydrogen atoms do you lose on the molecule? You can see ethane has the chemical formula of 2 carbons and 6 hydrogens. But when you have 1 degree of unsaturation, what does it go to? 2 carbons, 4 hydrogens. Now, if you add another double bond, that is adding another degree of unsaturation. So now we're at 2 degrees of unsaturation. What does the chemical formula change to? Do you see how every degree of unsaturation, so here's our first one, we go from 6 hydrogens to 4. We add another degree of unsaturation and we go from 4 hydrogens to 2 hydrogens. Every degree of unsaturation reduces the amount of hydrogens possible by 2. That also goes for when you have double bonds to oxygen atoms in this aldehyde compound. That double bond is responsible for 1 degree of unsaturation. Another thing that degrees of unsaturation helps us to understand is that for every ring structure, we lose 2 hydrogens, and that is a degree of unsaturation. So let me show you that. So if I draw hexane, 1, 2, 3, 4, 5, 6. So what's the formula? H6H. Let's count them up. 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Let's double check here. 6. Okay. So 14 hydrogens. Now if I take that and turn it into cyclohexane, still 6 carbons, what happens now? The chemical formula is now this. Do you see how when we went to the ring form, we have lost 2 hydrogens? So this molecule right here, the cyclohexane, has 1 degree of unsaturation. So in summary, every additional bond right there increases the degree of unsaturation by 1. And then, so here we have 3 bonds. So that's increased it from, we're going from this molecule to that molecule, 2 degrees of unsaturation. Okay. And then for every ring, we have a degree of unsaturation. So if I look at a molecule like this, how many degrees of unsaturation does that molecule have? Well, you see one double bond, so that's 1 degree of unsaturation. If you had something that looked like this, there's 2 double bonds, so that's 2 degrees of unsaturation. If we had, let's say, a 3-membered ring, how many degrees of unsaturation does that have? 1. But if I added a double bond, that would be 1 degree of unsaturation for the ring, and then an additional degree of unsaturation for the double bond. So this molecule would have 2 degrees of unsaturation. Now, what if we looked at benzene? Pause the video and ask yourself, how many degrees of unsaturation does this molecule have? Now, you should see that there's 1 degree for the ring, a 2nd degree for that double bond, a 3rd, and a 4th. So benzene has 4 degrees of unsaturation. So just by looking at a molecule, you can figure out how many degrees of unsaturation there are. Now, what if we do it in the opposite way? What if we only have a molecular formula? How do we calculate the degrees of unsaturation? So to do that, let's look through some examples here. What if I had that molecule there? How many degrees of unsaturation do we have? Well, in order to do that, we need to know this formula. 2n plus 2. That formula is going to tell us the maximum amount of hydrogens that could be in a molecule. Actually, not a molecule, an alkane. Okay. N here stands for how many carbons there are. So the maximum amount of hydrogens that this molecule could have is going to be 2 times 4, because we have 4 carbons, so the 4 goes there, plus 2. So what does that equal? There's going to be 10. So if we had an alkane with 4 carbons, we should have a formula that looks like this. That tells us how many maximum amount of hydrogens we should have. So this molecule right here is saturated because it has the maximum amount of hydrogens. Whereas when you compare this one in the circle, that is going to be unsaturated because it's missing 4 hydrogens. So what is the degree of unsaturation for that molecule? So what you do, how you solve this problem, is you write down the chemical formula that's given to you, and then you write down what the chemical formula would look like if it was saturated. So you're going to use this equation right there. And so that new formula is going to look like this. And then you're going to take how many hydrogens there are. There's going to be 10 hydrogens here. So you're going to go 10 minus how many hydrogens you actually have, which is 6. And then you're going to divide it by 2. And what does that equal? 10 minus 6 is 4 divided by 2, so that would be 2 degrees of unsaturation. Now, why do you divide it by 2? The reason why you divide it by 2 is because for every 2 hydrogens, that are missing equals 1 degree of unsaturation. So we can see here that how many hydrogens are we missing? There's 4 hydrogens that are missing. So we get a degree of unsaturation for 2 hydrogens, and then we get another degree of unsaturation for 2 more hydrogens. And that's what we see right there. Now things will get a little bit more complicated when you introduce heteroatoms. Right? So let's say if we have a formula that looks like this when we start introducing oxygen. What do we do now? Well, how do we calculate the degrees of unsaturation for that guy? Well, here's the trick. You use the same formula, 2n plus 2. You take the amount of carbons, put it in there for n. So 2 times 5 plus 2 equals 12. And so this formula right here, you pretend that there's really no oxygens present. Okay? No oxygens present. And so you're going to take this number right here and substitute it in for the amount of hydrogens. So the molecule is going to look like this. Okay? So what we're doing here is we're trying to figure out the maximum amount of hydrogens possible. Right? And when you have oxygen atoms in your molecule of interest, you just ignore that it even exists. And then you have this as your saturated molecule. Okay? Now we do the same thing that we did in the previous example. We're going to take the amount of hydrogens that you calculated by using this formula right here. You write that down. Then you're going to minus how many hydrogens you actually have, which is 8, divided by 2 equals 2 degrees of unsaturation. So that is how you handle molecules that have oxygen in them. You just pretend it's not even there. And you don't do anything with it. Now, what if you have, let's say, a halogen? So a chlorine atom. What is the degree of unsaturation for this guy? Right? Well, what we do here is we use the same formula. Right? So that would be, put in a 6 here. So that's going to equal 14 hydrogens. Okay? Let's see here. So that's the maximum amount of hydrogens. Now, with a chlorine atom, what we're going to do, let's see, I actually wrote down this formula wrong. There you go. It should be 6 carbons, 11 hydrogens, and 1 halogen. Now what you're going to do is now you're going to take the halogen and you're going to add 1 hydrogen. Okay? So you're going to take this molecule right here and you're going to rewrite it like this. C6H12. Okay? So we're adding 1 hydrogen for every halogen atom we have. Okay? And now what we're going to do is take the maximum amount of hydrogens minus how many we have divided by 2, and that's going to equal 1 degree of unsaturation. Now what do you do when you have a nitrogen atom. Okay. Well, let's first calculate the maximum amount of hydrogens. So that's going to be 16 plus 2 is 18 hydrogens is the max. And now we're going to adjust this formula. For every nitrogen you have, you are going to subtract one hydrogen. So that formula now looks like this. You see we've gone from 9 hydrogens to 8. Okay. Now we take the maximum amount that we calculated, 18, minus how many we have, which is 8, divided by 2 equals 5 degrees of unsaturation. That's how I was taught, and that's how I do it when calculating 5 degrees of unsaturation, or degrees of unsaturation, sorry. Now, there is another way to do this, and it seems to me that it's a whole lot easier, but that's not how I was taught. So there's this equation here that we can figure that out. So degrees of unsaturation, I'm just going to abbreviate that. It's going to equal this formula. 1/2 times 2 times the amount of carbons you have, plus 2, plus how many nitrogen atoms you have, minus how many hydrogens there are, minus how many halogens you have. And that will tell you the degrees of unsaturation. So now, in this way, you don't have to remember, hey, with nitrogen atoms, you take away one hydrogen. In a halogen, you add a hydrogen. With oxygens, you don't do anything. The formula would just look like this. And so this simple equation down here at the bottom just kind of takes away all of that. So if we redo our formulas here, you will see that we will get the exact same answers if we use this formula. So the degree of unsaturation for this compound is going to be 1/2 over 2 times 4, which is 8, plus 2, plus 0 nitrogens, minus 6 hydrogens, minus 0 halogens. So I'm just taking and plugging in everything. There's 4 hydrocarbons there, so I plug it in there. There's 6 hydrogens there, so I plug it in there. And the nitrogens and the halogens, I don't have any, so I just put in a 0 for those. And you will see that when you add that all up and divide it, it's going to equal 2 degrees of unsaturation. So let's take a look at this one. Just use the equation again. 2 carbons plus 2 plus a nitrogen minus a hydrogen minus a halogen. Well, 2 times 6 plus 2 plus 0 nitrogens minus 11 hydrogens minus 1 halogen. The X represents all the halogens, so that could be fluorine, chlorine, bromine, and iodine. And I have one of those, and then that's all divided by 2, and you will see that that molecule does in fact equal 1 degree of unsaturation. Okay? So I really like this equation here. It seems to simplify things, but I just have a tendency to go back to how I've always done it all these years, and this is what I showed you in this at the beginning here. Okay? So that is the end of degrees of unsaturation. If you have any questions or concerns, always remember you can reach out and I'll be more than happy to help.